role also for the world to develop new things, as well as we have to focus on the utilization of these inventions also. If it is wrong, then we must have to stop it also. My topic is wind energy, anatomy of modern turbine. As we are aware of, world is facing a lot of problem uh, in terms of electricity or electricity utilization or supply of electricity. So scientists have major focus on the alternate energy segments like solar, wind, biomass, biogas. Hydrogen is again a new technology. Last time uh, I discussed a lot about the hydrogen energy. So we started, we just have an introduction of the topic, harnessing the Gale wind energy, anatomy of modern turbine, powering a sustainable future in 2026. Next slide, please. The core principle when we are talking about a wind energy, how it is working, how it's supplied, which kind of energy is transferred, uh, from which energy to which energy, that is what we have to understand it, the core principle of it, how wind becomes a watts, how wind becomes an electron. First of all, the kinetic energy to mechanical energy. Wind flows over airfoil shaped blades. These blades are of wind windmills, you say it, okay, that is connected to the wind turbines that create lifts similar to an airplane wing. That in airplane wing that generate thrust in a horizontal form, here the same thing will develop in a vertical form. Mechanical to electrical energy, the second formation is the rotating blades spin a drive shaft connected to a generator. Okay, here is generator, the terminology known as the turbines. Okay, then this turbines or generator will generate electricity, grid integration. From there we connect it to the grids. A transformer steps up the voltage for transmission across the electrical grids. From there, when these turbines will move, electricity will generate, and this electricity move on with the step down transformer or step up transformer. Two kinds of transformer we will use it over here. Next slide, please. Then what kind of wind energy or types of wind energy applications we are using these days or we are implementing? First one is land based, onshore. The most common form where large clusters of wind farms are built in open windy areas. This is very common. Everybody we saw it across the world. The typical one is offshore. Turbine builds in large bodies of water. On islands we saw it, or in less deep sea area where wind is very high, we use it. Offshore winds are stronger and more consistent, but the engineering required is more complex and costly. Implementation of these wind towers is very tough and very complex also. Naturally, it is costly, but for a long run, it is very useful. Then third one is distributed wind. Small scale turbines located at the point of use, such as those powering a single home, farm, or remote research stations. Okay. This is a small scale turbines for residential purpose or for small factories, offices. We have to utilize it from 1 kilowatt to 100, up to 500 kilowatt models. That we have to utilize it at our home or in our offices or small scale industries. Next slide, please. Anatomy of modern turbine. What are the components we are using with the turbines? The key components we are talking about, a lot of things apart from that, but for as a technology, we are using these few specific parts in wind turbines. The rotors includes the rotary is the central part of wind turbine that includes blades and the hub that holds them. Nestles the brain box on the top of the tower containing the gearbox, generator and controller. Here we connect these blades also. The tower on which this nacelle will stand. Made of tubular steel. These days we are using steel because it is very easily to reusable, or concrete materials. Okay. Taller towers access faster, less turbulent winds. Nowadays we are using 3 up to 300 feet of tower. Okay. Anemometer and wind vane, sensors that measures wind speed and direction to optimize blade pitch and yaw. These are few very specific portions of wind turbines. Next slide, please. Comparing technology, when we are comparing, there are two types of wind technology we are using. First one is horizontal axis, that you saw it everywhere. Second one is vertical axis. So we just compare it with the features. Common use utility scale wind farms, that is supply to bigger factories or city kind of things. Second, at vertical axis, we are talking that this is for residential and urban areas. For small scale, we use it. Okay. Efficiency, very high efficiency in horizontal axis, HWT, we called it HWT and VAWT, vertical axis and horizontal axis wind turbines. Moderate turbulent winds for small, low speed wind, we are using it up to 2, 3, 4, 5 kilometer per hour also work out over here. Direction must face towards the wind. If wind is moving from north, then turbine must be at the north side, or wind is moving from south, or somewhere it is east-west direction also. No, mostly it is east-west direction. In a small scale, it is omnidirectional because the turbine we set up it at the base point. In horizontal axis wind turbines, the turbines are set up at the top of the wind mill. Maintenance in HWT maintenance is quite complex because components are set up at the top of the tower. In vertical axis, it's easier, simpler. It's a small one, and the turbines are at the base, so it is easy to operate it. Next slide, please. Now we are talking about the grid stability, storage, and hybridization. Hybridization word we are using over here. These days, hybrid models we are using, like with wind, solar, because solar we use it, we generate electricity only at the daytime. Solar have limitations of it. In night you cannot use solar technologies. Okay. Wind have on when the wind flows. So there are other kind of hybrid models are also using these days. Somewhere with hydrogen, with biomass, or with biogas. We have a lot of other options are also available. The main problem worldwide, the storage of electricity. This is the biggest technical hurdle. Intermittency is being solved by treating wind farms as hybrid power plants. Now, the same technology we are using it in solar industry also, as well as in wind energy. Battery buffering, it's a backup. Utility scale lithium ion and flow batteries are now co-located with wind farms. They have the peak of high wind productions and discharge during lulls, providing a firm power profile to the grid. Green energy, green hydrogen integration, just discuss about it. Surplus wind energy, when production exceeds grid demand, is redirected to electrolyzers. These machines split water to create hydrogen. which is stored and later used for heavy industry or long haul shippings. Grid forming inverters. Now, power electronics allow wind farms to provide synthetic inertia, which helps stabilize the grid frequency, a role traditionally held only by heavy spinning turbines in coal or gas plant. Coal and gas plant is quite tough, lot of pollutions that destroy environment. Uh, we are working in that industry is completely against the environment. So when we are comparing it with those technology, with thermal technology or a gas plant, it is very good uh, in categorization. You say it is very best for the environment. Next slide, please. Environment and social impact. How wind energy, wind turbines, that will directly affect the environment and what is the economic impact on it. Wind energy offers significant advantage but also faces unique implementation challenges like sustainability, no greenhouse gas emission or water consumption during operations. It is not required because it is a clean energy, green energy, we called it. Economic benefits creates manufacturing and maintenance jobs and provides income for landowners who host turbines because we set up this wind energy turbines to multiple land area where air is very high. Okay. Third one, what are the challenges? Intermittency, the wind doesn't always blow. Potential noise and impact on local wildlife, birds and bats, which researchers are working to mitigate. So these three points will directly impact on wind energy segment. Next point, please. The rise of offshore wind. This is going to be a very big technical development in year 2026 this year. Scale commercially, earlier we saw it, windmills are very small turbines are available. Small capacity of turbines like 300 kilowatt to 500 kilowatt. Later on, it developed to 1 megawatt. But commercially, standard have reached 15 megawatt. With new technology, it is 18 to 20 megawatt platform emerging this year. This kind of wind energy is coming. Wind energy turbines. These turbines with a capacity, a single turbine with a capacity of 18 to 20 megawatt. Like if you implement five wind towers, that will generate 100 megawatt of electricity almost. The advantage of it, offshore winds are stronger and more consistent than onshore winds. Near sea area or just you go in little deep area or islands, you get very high onshore winds. Floating winds technology is transitioning from pilots to large scale arrays, allowing turbines to be placed in deep water. That is what we are talking about, where fixed foundations are not possible. So in deep sea, it is not possible to implement. That's why we are using island kind of area or near beach area or up to 10 to 12 meter deep water. We can also implement it. Next slide. Modern innovations and artificial intelligence involvement in wind energy, because wind energy is a mechanical component and modern innovation, we have to guide it, we have to control it through AI technologies or software technologies. SCADA is very common software we are using these days. Technical trends that we are getting uh, the modern innovations, modern technology we are implementing from last couple of years, or the upliftment in 2026, smart maintenance, use of autonomous drones and AI based thermal imaging to detect hairline blade fractures before they fail. We can easily judge it out, the blades are working or not, or is there any kind of turbulence happened, there is any kind of crack or breakages are there. Advanced materials, increased use of carbon fiber and modular blade designs to reduce weight while reaching length of over 130 meters. These days blades we are using up to 130 meters. You just think of it, 130 meter of blade, almost around 400 fits. Okay, so the blades earlier, we use steel for blades, manufacturing of blades, but now carbon fiber and modular blades designs are used. Storage synergy, large scale wind projects are increasingly paired with battery energy storage system BESS to provide firm power even when the wind isn't blow. We just store this energy, this electricity in batteries, and after that we can utilize it wherever we want it. Next slide, please. What are the benefits and challenges in setting up these wind turbines? The balancing act, we called it. The benefits: zero emission during operations. There is no any kind of fuels is used over there. Natural air we are using it. Lowest cost per kilowatt hour in many global regions. Small land footprints, farming can continue. Means under this turbine, nearby area of the turbines, you can easily farm, you can make houses also. That's not a problem. Okay, what are the basic challenges of setting up of these wind turbines? Intermittency requires backup or storage solution. This is very crucial in alternate energy or any kind of energy we are using, either in thermal or in hydro. The similar situations is going on. Grid congestions, moving powers from remote wind sites to cities. Like if you set up any plant in any island, from that island, the residential or factory area is 20 kilometer or 30 kilometers. So you have to set up a grid connectivity also. Public perceptions, aesthetics concerns, and local wildlife bird bat impact. This is one of the main reason birds will hit with turbines or bats will hit turbines. So this is one of the basic reasons also or challenges. Next slide, please. When we are talking about the global outlook and future of wind turbines, we just make a roadmap by 2030. Market growth, wind is expected to provide nearly 90% of all new power capacity added globally alongside solar this year. By 26 to 30 or 32, wind and solar hybrid models is very popular across the world. Even everybody saw it in their country. Primary sources on track to surpass coal as the world's primary sources of electricity generation. When we are talking about 50 years back, thermal power is the only source, or hydro is the only source for generating electricity, and we are harnessing the natural resources like anything. For by 20, the global goal, the industry is targeting 1 terawatt of additional installation by the end of the decade by 2030. Means 1000 gigawatt wind energy is going to be implemented across the globe. Next slide, please. Conclusion, wind energy is no longer an alternative, it is a pillar of the global grid. We saw it very clearly across the world. Wind energy is implementing now. It is not an alternate energy. It is one of the main generation of electricity. We are getting it from wind turbines. Technology is moving towards bigger, smarter, and further offshore. Efficiency gains and AI integration, involvement of software, are making wind the most competitive energy source on the planet. Later on, the things were moving fast. Seashore areas, we have to implement these wind energy. So we have to save our environment very easily, from dam or from thermal energy that will destroy our environment like anything. Thank you, all of you. If you have any query, you can ask me or you can write into my email also. You can visit also our website for any kind of query or any kind of setup or any kind of consulting support from our end, or for the research and development. We set up a new mm, R&D division for this, and we already associate with many organizations across the world, and most welcome for the association also. Thank you a lot to all of you.
Okay, thank you so much for the presentation. And if there is any question or any contributions from our participants, please go ahead. Okay, Doctor, there seems to be no questions for now. Thank you again for your presentation, sir. Thank you so much.
Thank you. Welcome.